The purpose of this video is for you to see visually the EPA to the AREPA process that we will follow with the elimination method. The EPA to the AREPA requires that we evaluate, process, and ascertain. EPA. So, as we can see, we have a system of equations. We have equation 1, 3x plus 2y equals 9. And we have equation 2, 2x plus 6y equals 6. Now, as the EPA to the AREPA system goes, we must first evaluate it. And when we evaluate, we must say, what common factor can be used to eliminate a variable? Notice that we have 3x and we have 2x. We won't be able to eliminate them. And we also have 2y and 6y. So we will not be able to eliminate them. The coefficients of one of the variables must be the same in both equations so that the variable will cancel out when one equation is subtracted or added from the other. In this example, we are going to eliminate the x variable to be left with our y variable. To make 3x and 2x equal, we must multiply all terms on each side of the first equation by 2. And all of the terms on each side of the second equation will be needed to multiply by 3. The result of the first equation is going to be 6x plus 4y equals 18. The above expression in standard form is still true even if we multiplied both sides of the equation by 2. Now in the second equation, we had 2x plus 6y equals 6. Multiplying it by 3 on both sides of the equation will result in 6x plus 18y equals 18. Now that we have the same coefficient variables of 6x and 6x, we're going to be able to move on to step 2, the process. In step 2, the process, we are going to eliminate one of the variables. As both 6x and 6x are not opposites and of the same positive and positive, we know that we can eliminate them through subtracting. When both systems of equations are subtracted, in this case, together, we have 0x, 6 minus 6 is 0, 4 minus 18 is negative 14y, that's the variable, and 18 minus 18 gives us 0. As our x variable has now been eliminated, we can have negative 14y equal to 0. But the question is, what is y? Well, clearly, anything times 0 is 0. So y is going to be 0. Now that we know our y-coordinate, where the two linear equations intersect, we can input our y-coordinate into either one, it's very important, either one of our equations below, the ones that we had originally, and we're going to get the same result. Observe. Knowing that y equals 0 in both equations should hold true for our x variable, let's see what happens. So in equation 1, we will input 0 into our y variable. 2 times 0, well, that's 0. So that gives us 3x equals 9. What is our x? Well, if we divide both sides by 3, we're going to get x equals 3. Let's double check that with equation 2. If we input 0 into our y variable, well, anything times 0 is 0. So that gives us 2x equals 6. What is our x variable? Well, 2 times 3. equals 6. So clearly, we've found that our answer is x is 3 and our y variable is 0. It's very important that we write this in the correct format. The correct format for this to be written in is as a coordinate, because it is the coordinate where both standard equations that we had originally, 3x plus 2y equals 9, and 2x plus 6y equals 6, the coordinate represents where they both intersect. Let us observe that visually. Visually, well, we can always graph these equations on a graphing calculator. And when we do, it results in a point where they both intersect. And clearly, we can see on the graph that they are intersecting here at the point 3, 0, visually. But algebraically, we calculated that it was 3, 0. So we have the right answer. I hope that the elimination method is one that you apply in the future, because it is an easier method than the substitution. A reminder of the steps: EPA to the AREPA. Evaluate, where you have to make sure that you have the same coefficients for your variables to eliminate one variable. And then you process it through addition or subtraction to eliminate the variable, which then gives us y equals 0 in this case. And then we do the A for the EPA, which is ascertain, the other variable, where we input. We only need to do it once, but for the purpose of the video, I did it twice to show you. Y equals 0 and y equals 0. You can input 0 into either equation and it will result in the same answer, x equals 3. The same answer. So the final answer of where both equations intersect is 3, 0. I hope this video is useful for you when you do autonomous work. I'll be in office hours should you need any help. Have a good day.